Welcome to lesson number 5. Today we're going to be looking at evaluating logarithms, and we're going to start by evaluating these logarithms by converting to exponential form. And we're going to look at this investigation where Kelsey is asked to evaluate log 2 of 8. Her work is shown below, and we want to study her work and describe each step on the lines provided. So first of all, we have the expression written log 2 of 8, but it's set equal to v. Now the reason we set it equal to v is just so we have another variable to work with. And in this case, v just stands for value and our unknown value. Now the next thing that we want to do is change to exponential form. So if you notice that 2 is the base of our logarithm, which then becomes the base of our exponent, and then 8 and v becomes the exponent, and the argument 8 becomes the value of this exponent. And so what she did next here was changed to exponential form. The next thing we do is we make a common base. And so if I have the exponent 2 to the power of v, which is equal to 8, remember I can express 8 as a base of 2, which would be 2 cubed. And so we make a common base. Now we can get rid of our bases and compare our exponents. So we drop those bases and compare the exponents. Can't spell right now. Exponents. And the last thing we need to do, so v is equal to 3, is replace v by log 2 of 8. Since v is equal to 3, and if we look at our original expression, v is equal to log 2 of 8, therefore v is equal to 3. And therefore log 2 of 8 is equal to 3. Now we're going to take the same approach with these examples in class example number 1, where we're going to evaluate the following logarithms. And so first of all, we're going to set them all equal to v. So that's the first thing. Then we're going to change to exponential form. Then we're going to find our common base and then compare exponents. And then lastly, replace our value by whatever log we were working with. So first thing I got to do is set this equal to v and then change to exponential form. Exponential form, this would be equal to log is equal to 3 to the power of v. 81 can be expressed as 3 to the power of 4, which is equal to 3 to the power of v. Therefore, v is equal to 4, and my last step is to replace v by log 381. And so log 381 is equal to 4. Now with this example, we have 1. Now remember, if I have a base 12 here, I can make this 1 a base 12 by just saying 12 to the power of 0 is equal to 12 to the power of v, and therefore v is equal to 0, and I can make that replacement with log 12, 1, which is just equal to 0. Now let's look at class example 2, where we have 2 logs where we're working with the variables as our bases. And this one has a variable as the argument. So let's tackle this one first. Exactly what we're doing before, set this equal to v, and then change to exponential form, where 1 is equal to b to the power of v. Now remember, whenever we have 1 and we want to express that as the same base as our exponent, then this just is going to become b to the power of 0, which is equal b to the power of v. And then it's just a matter of dropping our bases and comparing the exponents. And so here we would have v is equal to 0, and then we can make our substitution, where I would have log b of 1 is equal to 0. Now I have my next example, log b of b, and we're going to set this equal to v as well. And then I'm going to convert to exponential form, where b is equal to b to the power of v. Now, I have a base of b, and I have a base of b here as well. And if it's just b with no exponent, that means the exponent is actually 1. And so b to the power of 1 is equal to b to the power of v, and v hence is equal to 1. And so if I make that replacement, log b of b is equal to 1. Now notice that whenever your base and your argument are the same, it's equal to 1. Just like the one that was log 7 of 7, that was also equal to 1. So if it's log 10 of 10, it's going to be equal to 1. Next, let's look at class example number 3, and we want to evaluate the following logarithms. So 2 times log 8 512, and we're going to begin this the same way. We're going to set this equal to v, and then we can solve. Now, remember, the operation between the 2 and the log is multiplication. So I can actually divide both sides by 2. This is going to leave me with log 8 of 512 is equal to v divided by 2. And if I want to now, I can set this I can set this to exponential form. So 512 is equal to 8 to the power of v over 2. Now 512 expresses base of 8. Now we know 8 squared would be 64. So 8 to the power of 3 is 512. So we have 8 to the power of 3 is equal to 8 to the power of v over 2. And we can now just compare our exponents, and so we would have 3 is equal to v over 2. And now I can solve for v by isolating my variable and multiplying both sides by 2. So bring this 2 back up here. That would be 3 times 2 is 6, which is equal to v. And the last thing we got to do is replace this value of v with my log. And so 2 log 8 of 512 is equal to 6. And we'll take the same approach for this one here. We set this equal to v, and there's no coefficient in front of my log, and so I can just start by converting this to exponential form. So 1 over 32 is equal to 2 to the power of v. Now 1 over 32 is the same thing as 1 over 2 to the power of 5, and there's where my base 2 is going to come from, is equal to 2v, but I'm going to have to express this as a negative exponent. 2 to the negative 5 is equal to 2 to the power of v. And v is equal to negative 5. And the last thing I got to do is make that substitution. Log 2 of 1/32 is equal to negative 5. And last, we have log 5 of the square root of 125. So we're going to start right away by, same thing, setting this equal to v, and then converting to exponential form. So square root of 125 is equal to 5 to the power of v. Now, 125 here, if we have square root, this is not a perfect square number. So instead of expressing it like this, remember we can express it like so, is equal to 5 to the power of v. And now we can express 125 as a base 5. This is going to be 5 cubed to the 1/2 is equal to 5 to the power of v. And if I use my exponent laws, my power of a power, I can multiply this into my 3, and that leaves me with 5 to the power of 3/2 is equal to 5 to the power of v. And so v is equal to 3/2. And log 5 of 125 is equal to 3/2. Last, let's look at class example number 4. We want to evaluate 5 log 5 of 25, 5 to the power of log 5 of 25. And next we're going to look at class example number 4, where we're going to evaluate 5 to the power of log 525. Now, this looks a little intimidating because our log is now an exponent on this base. But the process for solving and evaluating these is the same, where we just take log 5. So I'm just going to take log 525. I'm going to solve this individually. So apart from this 5 here, from my base. And so I'm going to set this equal to v like we usually do, and then I'm going to convert to exponential form. So 25 is equal to 5 to the power of v. And we would find our common base. 25 is the same thing as 5 squared is equal to 5 to the power of v. And we can get rid of our bases now and focus on our exponents, and the value of that is equal to 2. And so v is equal to 2, and that means that log 5 of 25 is equal to 2. So if we were to express it like this, 5 squared, then this entire log is equal to 25. And we would take the same approach with these two here. I'll skip this one and I'll do this one here. I have 3 to the power of log 3 of 27, and so same thing. I'm going to say that log 3 of 27 is equal to v, and I'm going to solve this. And I'm going to begin by putting it into exponential form. So 27 is equal to 3 to the power of v. And this would be 3 cubed is equal to 3 to the power of v. And v is equal to 3. And so if I make that substitution up here, then I would say that 3 to the power of 3. And let me take it one step before this. I'll say 3 to the power of log 327 is equal to 3 cubed, which is equal to 27. Now, based on your observations from A to C, what is the value of a to the power of log a to the n? And we want to use inverses to explain our answer. So and if we were to do this one, it's going to end up the same way. But if we look at the argument here, here, and here, that is the value of our expression. And so if I have a to the power of log a to the n, this would equal whatever value that n is. And so if we raise a base, so raise a base to a power, and take the logarithm to the same base, they're going to be inverse operations. So you're basically undoing that operation that you just did. Now we're going to take a look at this investigation, and we're going to evaluate logarithms by changing the base. So we want to try to evaluate log 5 of 50, and we're going to probably encounter a problem. So if I have log 550, which is equal to v, we would begin by setting this or converting to exponential form, where 50 is equal to 5 to the power of v. Now, usually what we do is we find a common base, and prior to this example, finding a common base has worked every time because we've been working with perfect cubes or perfect squares, and so we can find that common base. But now I have a number like 50 where I can't express as a power of 5. So 50, and that's the problem. 50 cannot be expressed as a power of 5, right? Because if I had 5 squared, that would be 25. But then in between there, it was going to be 50 somewhere, but 5 cubed, which is my next exponent, it'd be 125. So choose the correct alternative. The exact value of log 5 to the power of 50 is, and this is the thing, right? Like when we're using logs, essentially what they're doing is solving for an exponent. It's telling us what repeated multiplication we're using to get a value. And if I find out what that is, it can't be 1, right? Or it can't be option I here between 1.5 and 2, because that would be a value below 25. So let's see, between 2 and 2.5, it could potentially be that, because if I have 5 squared is equal to 25 and 5 cubed, which is equal to 125, the value to get 50 would have to be in between 2 and 3. So it's likely going to be between 2 and 2.5. Probably not between 2.5 and 3, because that value isn't getting too high. Now, at the moment, we are unable to evaluate log 550 by converting to exponential form, but we can use a calculator by changing the base to a base the calculator recognizes. And in order to do that, we're going to be using common logarithms and natural logarithms. All right, looking at common logarithms. So common logarithms are logarithms in base 10. So an example would be log 10 of 1,000. So these logarithms are in such common use that sometimes this base isn't even shown. And if it's not shown, then that means that we're using a base 10. So for example, if I have log 10 of 1,000, it's often written just as log 1,000. And you can use your graphing calculator in order to evaluate these types of logs. So as an example, the log button on your calculator is something you have never used, but I know you've always wanted to. So now is the time you can use your log button. And we're not going to do it yet. We'll do it for the next example. So let's look at class example number 5. Evaluate log 1,000 by first converting to exponential form. So remember that if it doesn't show a base, that means it's log 10. So I'm just going to rewrite this as log 10 of 1,000, and using our procedure, I'm going to set that equal to v, and then I'm going to set this to exponential form. So 1,000 is equal to 10 to the power of v, and 1,000 can be expressed as 10 cubed is equal to 10 to the power of v, and so v is equal to 3, and log 1,000, or log 10 of 1,000, is equal to 3. Now, the easy way, again, is to use your calculator. So log, and that's what I do. I just press log, and then I type in 1,000, and I get my answer of 3. And so log 1,000 is equal to 3. All right, let's look at class example number 6. So in each of the following, we want to estimate the value to the nearest whole number without using technology and explain the reasoning. And then we want to approximate the value to the nearest hundredth using technology. So first of all, log 10 of 89. Well, if I have log 10 of 89, and let's say I were to set this equal to v, and then 89 is equal to 10 to the power of v. So if I were to raise this to an exponent, what exponent would it be? Well, if let's say 10 to the power 1. Well, I know that's just going to give me 10. That's really far from 89. But I know if I go 10 squared, that's going to put me over. That's going to be about 100. So that being said, it's got to be in between 1 and 2. But I'm going to guess it's going to be like on the higher end, closer to 2. So they want us to estimate and round to the nearest whole number. So I'm just going to say my estimate is 2. And now we want to use our calculator in order to determine this. So log, and we're going to be inputting our argument here of 89, 1.94900 or 1.949390007. But they want us to round to the nearest hundredth, so I'm just going to round this to 1.95.